So let's proceed to our next session. So our next instructor is a manager of Telecom Infra Project Community Laboratory at Telcom University. He started his telecommunications career in 2001 to 2003 with an internship at PT Indosat. After that, he continued his studies at the Department of Electrical Engineering at Gajah Mada University in Yogyakarta. Then he restarted his career on the RF field, roamed various islands in Indonesia on cellular network deployment projects, becoming a team leader and after a project manager. His biggest passion is sharing and coaching, which led him to create a training program for fresh graduates like CNEC or the Cellular Network Engineering course in 2019. It was a program with a concept of mastering end-to-end cellular networks from the very basic, combining on-class theories and best practice experience sharing with the industry practitioners. Starting in 2020, his experience and passion brought him to his current position as a lab manager at TIP Community Lab, which has a vision of community development. Ladies and gentlemen, let's welcome Danny Francisca.
Thank you,
Hello,
Richard.
Danny.
Hello, Richard. Thank you for introducing me, and thank you all for having me here. It's an honor to join this session, and I hope this session can also collaborate and elaborate with Josil's previous explanation. So I hope Josil is still here to discuss together with me and the upcoming participants, because we will have some selected participants to directly try accessing the remote access. Yeah.
So I believe
Richard,
that
please.
you have sent them their access through email.
Yeah. So I still have a coordination with my team that creating the VPN access.
Okay.
The access will be sent to the respective participants. So please mention, maybe you can share also, Richard, the name that will receive the access, so they can aware to check their email inbox.
Yeah. Let me just show the list.
So for those who the name is listed here, please starting to check your mail inbox, and that will be a small requirement on installing particular software, mobile XTEM, to access the remote lab. It will take not a long time, so just take your time to install the software to set up the connection. Just follow the instruction sent in the mail. So Richard, I got confirmation it is now ongoing, sending to each participant listed here. So meanwhile, we can discuss.
Okay.
Yeah. So I'm enjoying very much the session from Josil. Just to make it in a simpler sentence, yeah, to everybody that already has experience previously in cellular network, maybe, and for everybody that also new learning this technology. Actually, so far our experience using our handphone, there is a full bar signal. It is provided by RAN evolving from 2G, 3G, 4G, and then maybe already 5G now in the Philippines. Actually, it is the same concept. It is just running the function of the OSI layer 1, 2, 3. So basically talking about RAN in 2G, 3G, 4G is talking the same thing. Talking about OSI layer 1, layer 2, layer 3. For so long time, since the 1G, 2G, 3G, and even 4G, the RAN equipment is coming with a monolithic building block. It is built by one single vendor, from end to end, from hardware to software. They design and manufacture everything from end to end, and nothing we can do instead of just installation, commissioning, and then maybe optimization, doing drive tests and so on and so on. So by this open run movement and then training like this, we can get an opportunity getting closer to the systems. What make me interested is actually looking at the ORAN architecture. Deep dive into RIG seems or looks complicated for some people, but to make it simple to us, actually everything explained in the ORAN architecture is actually already manifested in previous system, but they make it on their own way per vendor specific. Maybe somebody that already working in Nokia, in Samsung, Huawei, in Ericsson, they will be familiar. Okay, we know this as a, they call it sometimes feature. This is unique feature from vendor X. This is unique feature from vendor Y. This is unique feature from vendor Z. Okay, so if I may make an analogy, the standards say if you want to make a car, what we call a car is vehicles with 4 wheels, and the wheels must be in a rounded shape. This is called standard. Then everybody that manufacture car will make differentiation on their product. Okay, car is a vehicle with rounded wheels, but my product, the wheels will be solid rubber without any air. So if there's something heavy with the wheels, then my car, my product can still carry on. Something like that. So every vendors try to make differentiation on it. So they can call it their feature, their uniqueness and everything. But actually we can group their approach into the discussion like, okay, this is virtualization. Actually they, and maybe we can also approach, make an approach. What actually they do is actually build some microservice to optimize, microservice to detect neighboring relation between cells, microservice to detect interference. So far we know, and because they also introduce this as a special feature from their product. Now in the era of Open RAN, where the expectation is RU, DU, CU can come from different vendors. Not only that, the hardware, the software can also come from different vendors. The question, big question come, whatever we have from previous approach with this monolithic building block provided by single vendors, and we already enjoy that, how it will come in the era of Open RAN, where everything comes from different vendors, how to organize, how to orchestrate, how to consolidate this. That's why we need a reference. If you see, ORAN Alliance presented previously with by Josiah is actually not a single standard exists actually. Open RAN is not a technology, it's some kind of industrial approach that let us build the RAN so everybody can make. If you have proficiency on developing hardware, you can focus on your hardware, especially on radio unit. If you are very good on programming, you can focus on making R apps or X apps and so on and so on. And then industry needs a reference. That's why there is actually not only single SDO or standard defining organization. There is more than one actually. ORAN Alliance or ORAN architecture just presented is actually one example of it. But if you explore more, even for the RAN functional split, not only single body proposing about the split, but they refer to the same things. What is the same things? It is OC 7 layer functioning layer 1 2, and 3. 1, 2, 3. There is a breakdown task on it. Task 1, task 2, task 3, and so on, from VSY until RRC or RSDAP. And then everybody can interpret on which section the split is made. 3GPP as a prominent standard organization say, let us make the split option into 8. 1, 2, 3, 4, 7, 8. And then because split 7 also has so many tasks to do, then there is a breakdown of split 7. 7.1, 7.2, 7.2x, 7.3, and so on and so on. In the other hand, we have also heard about SCF, small cell forum. They are not defining the split into 1, 2, 3, 4, but they give the name of split is based on the border between layer and so on and so on. And also maybe we can hear about from NGMN and so on and so on. So I just want to emphasize that actually Open RAN can be found in any various way and approach, but the spirit is the same. RAN can be built not a single monolithic block like previous, but it should come as you build something with Lego, you can name it. So you can build some castle, some vehicle, or whatever from single brick with different colors, that at the end you can have the shape you want, and we call it RAN. So that's the idea of RAN. And then in comparison, in previous RAN, okay, we know how to get the inventory data, how what is the power being used, what is the resource being used, and so on and so on. We call it inventory management. And in Open RAN, in the opposite, we must map this into certain function block, and we can find it on SMO, like Joshua already explained. And then on previous vendor that we already have interaction with them, we know about automatic neighbor relation. In the era of 2G and 3G, maybe we create the neighbor relation manually, but in starting on 4G, we have automatic neighbor relation. And now in the era of Open RAN, ORAN, and in the ORAN architecture, we know this as a function of part of near real-time read. And then the discussion is going through. Okay, after all of the explanation, we would like to know how Open RAN vendors implement this on their systems. And Joshua already give good examples. Nokia and something have their X apps for this and this. Parallel wireless have their X apps for virtualized 2G BSC, 3G RNC, and 4G X interface. And on this session, practicing directly to the lab setup, we would like to know how it will looks like in a practical way. So before I continue, I would like to confirm, Richard, could you help me please to confirm maybe 1, 2, or 3 participants that the name listed, are they already received the email?
Some of them are just downloading the Mobox term, and then JM is asking if the host name or the IP address also shared.
Oh, okay. So I will share it on the chat box, yeah. Or you can follow this one.
Okay, so then is will be sharing his screen.
Yeah. So you can put the host IP to this one. Admin is for me. For you, you can fill with this one. Student 1 or 2 or 3 or 5 until 8.
So they will use the username student1 up to student8.
Yes, correct. If you are new installed, you can start from click this button, yeah, session.
Okay. Now
Yeah.
JP Paga is taking the student7 username.
Okay. Okay. Meanwhile, I will give some bridging material to everybody. So the concept of this session delivery, it is actually adopting the training delivery on the TIP lab in Bandung. So online participants is like we have now. So they are accessing to a real lab in Telkom University by using VPN. And okay, we have end-to-end setup here. So we have antenna in a chamber, RF chamber, and then we have parallel wireless integrated RU and BBU. If you remember, on Jose's explanation on run functional split, there is actually RU, DU, CU with various implementation. RU, DU, CU all spirited. RU spirited and then integrated DU, CU. RU, DU integrated, then CU spirited, and so on and so on. So there is so many variation. But in this context, in the lab, we have integrated RU, BBU for 4G, or you can interpret this with RU, DU, and CU integrated into one device. So this is the equipment. So the vendor we are using in the lab is from Parallel Wireless. They have their specific and unique solution. They called HNG, HeadNet Gateway. But here in my slide, I changed the terminology into run aggregator, because on previous session we don't intentionally we don't show the brand or the vendor, but now I can disclose this is coming from Parallel Wireless. They call it HNG or HeadNet Gateway. What is HeadNet Gateway containing? It contains COT server, and then Linux operating system laying down, and then on top of that they install their software. It can be virtualized 2G BSC, virtualized 3G RNC, and then we can also have virtual ENB and so on and so on, and also aggregating and then function for configuration management and everything. So if the question is where is the rig located on Parallel Wireless, they install it here on the device. We call it HNG. Okay. And then this is the context that I need to explain. Previously in the reference standard, if we have E node B, it will connect to core network via S1 connection. One node B, two node, second node B, third node B will have their own S1 connection towards core network. But here, I put separation border here. In Parallel Wireless, if we have one node B, first node B, second node B, third node B, fourth node B, and so on, they will have S1 connection goes to HNG, or I call it run aggregator. And then from HNG, it goes to core network with single and aggregated S1 connection. So this is the context. And then for everybody that new on this subject, so this is the appearance of the integrated RU, DU, and CU. So physically, it looks like a single RU, but actually it is integrated RU, DU, and CU integrated. Why it is integrated? Because if you remember Jose's slides previously, there is depends on the approach of the product, and this kind of product it's suitable for rural area use case. So it will be very handy, faster on installation. And then you can also consider about the latency requirement and everything. So are you DUCU integrated here? Everything is already done on site. And if we have only limited backhaul, we don't have fiber optic, we don't have microwave, but we have only, let's say, satellite connection. And that will be okay with this kind of configuration. Are you DUCU integrated in a single equipment? So this is, I have a video here just to show you the light from green, orange to green, and then blinking or not. It is just to give indication about the working status of the equipment. Previously, this slide is designed for operation and maintenance, but for this session, we try to enrich the explanation from Josil previously about a rig that you can now see whether this is an RT rig, whether this is a non-real-time rig. And maybe Josil can also elaborate as well. Okay. And we will access the HNG with CLI, command line interface, to see some function here. And then we will have some another exercise here. And if the time is sufficient enough, we will continue to the next step of this basic practice. Okay, is there anybody from the list that can join me on practicing it directly?
I think JP is already in. JP, can you confirm if you can join Denny? You can unmute your mic.
Yes, sir, I am in. And can I see the command, sir, Danny?
Okay. So everybody is asking about the password now? Yeah, okay. The password is if you are student 1, the password is password 1. Let me check, yeah. Who will share the screen, please?
JP, can you share your screen? Okay, JP is now sharing his screen. Thank you, JP.
Okay, so student 1, password 1. I write in chat box. Student 2, password 2, and so on. Okay, so this is you already entering the HNG now. Some basic function you can try. Number 1, you can see to show the operating system by typing show resource. Okay, could you please type show resource? Hello, Jay.
Wait, sir, I'm just mixing up my windows. Can you tell me, sir, again the command? It's
Yeah. Show
what? Okay.
resource, show space resource. RES, then you can press tap button. Okay, good.
Okay, sorry.
Show resource system. You can also apply sys tab for fast typing.
Okay.
And then space system OS name. System underscore OS name. System. No. System. OS name. Okay. What you can explain to us here from what you get?
So the system is using Linux. It's running in Linux.
Okay. how can you relate this with the topic of Open RAN?
Linux is an open source software, so
Mhm.
anyone can download and install Linux. And since Open RAN is endorsing the software and hardware and interfaces should be open.
Yeah.
Linux support that initiative.
Okay, so like this, we can say Open RAN in a quite simple definition. If it is allow us to build the hardware with COTS, commercial of the self server that you can buy from anywhere, any brand, it already fulfill the Open RAN definition. Talking about RU-DU-CU, adopting the design of RU-DU-CU doesn't mean you already implement Open RAN, because non-Open RAN vendors also refer to the same building block, because this is a very common standard coming from 3GPP. They are talking about RU-DU-CU, but they can implement their RU-DU-CU with their own design hardware, their own design software and everything, being very close system. So we call it as a monolithic building block. But in the right hand, we can implement RU-DU-CU with open approach or open RAN, we call it. If we can buy the hardware from open market, any brand, any vendor for the server, and we can install Linux on there as the operating system or whatever it is, and then we can install the service on top of the operating system with different software vendors, then it's already fulfill the Open RAN criteria. But for further development in industry, you can imagine if in the industry, in the network, if everybody is coming with their own interpretation of implementation of Open RAN, it will be very difficult to scale up. That's why there is an initiative like TIP is promoting the member to make the product, and then there is another standard body like ORAN Alliance. They have several working group, and the result of the working group hopefully can be adopted by the manufacturer. And also, if you remember from the previous slide, even from the SCF, they also group the product into 1, 2, 3. It can be come as a proprietary solution. It can come with a functional split solution by selecting certain split option. It can be come as a product with blah 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 and so on and so on. So Open RAN standard is not a single standard until today, but yes, there is a mainstream standard. One of example is ORAN Alliance. But for this session context, we just want to emphasize that Open RAN is a industrial approach actually, and you can see now from parallel wireless, they have HEADNet gateway solution. They built this with Linux operating system, and we would like to see what kind of server they have in terms of machine. Okay, Jay, could you please help me to show resource system underscore machine type? Show resource tab. Good. Resource. Okay, very good. System space system again underscore machine type. Machine like engine machine. Machine type. Okay, what you can tell us from here, Jay?
So this VM is using an x86 architecture or hardware.
Yeah, and it doesn't state the brand, right?
Yes.
It means that whatever the brand, as long as you have this type of machine, it can work. Then it's already satisfied the concept of Open RAN at the very beginning. For sure, we will talk about rig, we will talk about SMO for further development. But if you explore, and maybe you have a question to the vendors, they might be fully adopting the ORAN architecture, or they might be partially adopting, or they might be would like to adopt all, but not now. So they have some kind of roadmap. So maybe in 2023, we will have fully adopted ORAN Alliance standard, or maybe, and so on and so on. So please don't be confused, because very high hype or expectation with this Open RAN, there might be some misconception in the public that they are expecting, show me the O1 interface, show me the A1 interface, show me the E1, E2 interface, show me everything in a particular vendor. But in the same time, the vendor we have, the vendor we know, sometimes just partially adopting or not yet fully adopting because of their product roadmap and etc. But it doesn't mean what you call it. But it doesn't mean they are not adopting Open RAN. No. At the very beginning, concept of Open RAN is as long as they can use COTS, commercial off-the-shelf server that you can buy from the market based on this architecture. You can install Linux as the operating system and so on and so on. Actually, it is already satisfied the Open RAN concept. Okay, Joe. So, okay, what you accessing now is actually at headnet gateway or the RAN controller. So we will now check the RU DU integrated equipment by running show space access node ACC tab. Okay, access nodes with S, yeah. Access nodes LJ.
Yes, sir.
Access nodes with S. Okay. CWS. CWS is a parallel wireless naming for their inode B. CWS space resource system without underscore. Okay. Resource space system. Okay, what you get? What is the machine type?
Okay. The machine type is ARM x86-64. And the OS is Linux with version 3.0.51.
Okay. So this is the building block used in the inode B site. Yeah, inode B means RU and DU integrated. So they have another information here, or operating system release, right? Okay. And now please show running config. Okay, good. Access nodes, ACC tab. Just tap, press tab. Okay, good. CWS LTE cell. CW. Okay. Control C. Control C. Okay. Repeat with up arrow. Control C. Sorry. Control C. Okay. Repeat the command with up arrow. Okay. CWS space LTE space cell. Enter. What you see here, the port number. Okay. You can click. Control L. Control L. Okay. Can repeat the comment. Okay. What information you get from here? Hello, Jay.
Hello. So
Yeah.
the site is running on LTE. It
Mhm.
has with port number TRX 12.
And then tracking array code 0001.
And the frequency is 10 megahertz.
Okay, it's 10 megahertz. And then how about the band?
And band 8.
Band 8 means 900 megahertz, right? And then release R8 maximum subscribers. Hello, Josil, are you still here? Hello, Josil.
I think Jocelyn is
Already left?
yeah, already left.
Yeah. Okay, Jay. Do you remember about Josil's explanation about what is non-real-time rig and then real-time rig? What is X apps? What is R apps? On this CLI command, we can get information like how many port is being supported, and then how many what megahertz it being used, 10 megahertz, and what band is supported, band 8, what ERFCN in the setting 3625, correct, Jay?
Yeah.
We can say this is a part of inventory management. So everybody can refer back on which part inventory is laying down. It is on in the part of SMO, or in the real-time rig, or in non-real-time rig? What do you think, Jay?
For this
Or this is in
information,
the part of SMO?
I think the information also is being received by the SMO.
By
the
SMO, right?
company.
Okay, but we can say this is the SMO version of parallel wireless. Agree, Jay?
Okay.
Yeah, in this lab, everything is coming from parallel wireless. The Inode B, the HeadNet gateway, the software for Inode B, the software from HeadNet gateway, all is coming from parallel wireless except the hardware itself. So it's already already fulfill the criteria of Open RAN. So don't be misunderstood. Open RAN must coming in a various different color of Lego, you can say. It also came as a same color Lego. As long as the disaggregation is there, the hardware is coming from another vendors, but anything else can also come from single vendor like this one, like parallel wireless. So on this case, this we can say this SMO version of parallel wireless. What we see from previous session, we have ORAN standard. Oh, this is SMO, this is O1 interface, A1 interface, everything is connected through a northbound interface, southbound interface, and everything. This is a reference architecture. If we want to build everything, and everything can be works and interoperable if it is in a multi-vendor environment. So what if I build this by my own? If this is built by parallel wireless end-to-end, so it is actually up to them to make it. Okay, this is my version of SMO. This is the version of parallel wireless. And maybe you can see if another vendor, let's say Malveneer and maybe another vendors, we can have same question, whether Malveneer already 100% adopting ORAN standard with all the interface and building block, or they just, for now at least, adopting partially the reference. But if every different vendors wants to be orchestrated into a fully interoperable Open RAN, they must refer to that ORAN Alliance standard at least. So if that's the case, we can have a question, show me the O1 interface. Where is the SMO part? How to know, how to access the inventory management part? How to know about the automatic neighbor relation function, and so on and so on. Here, in parallel wireless, they also have what they call automatic neighbor relationship as their part of SON, yeah, self-optimization network. If you remember, on Josiel's slides, ANR is part of X apps. Correct me if I'm wrong. X apps application. So actually, what we access here, what we can see, what we can configure here is a result of X apps and R apps. But every vendor can have their own version of R apps or X apps. Or even they can also define by themselves as long as that function, that objective is achieved. But the case is different if the vendors want to be considered as fully adopting ORAN Alliance standard. For example, they must develop R apps and X apps based on that standard. So they must have O1 termination, E1 termination, and so on and so on. Could you get the idea, Jay?
Yes.
Yeah. So I would like asking you to check one more comment. Show access nodes, CWS, LTE, show access nodes, CWS, LTE, cell, okay, space, OPER, 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 dash data, dash without S, minus data. Good. Data. Okay. What is the information we get from here?
The site is in service.
The site is in service. How do we know? Because the status stated as in service, correct, Jay?
Yes, correct.
Yeah, but actually this is the result of function that we can call it as operation and maintenance, or OAM. Then you can refer back to previous session with Josiel. OAM is a function of X apps or R apps. This is near real time or non-real time?
It's a real time.
Real time or non-real time? Real time, near real time requires less than 1 second. It's like a radio resource management. But something that needs more than 1 second, like data training for machine learning, for making decision, what is the next cell condition and everything, it is grouped on non-real time, right? But we can now together also check the OAM function. It is grouped on SMO or non-real-time function or near real-time function. Then we can start interpreting like this. I mean like this. If you log into parallel wireless system, if you log into Mavenir, if you log into Ericsson, if you log into Huawei, if you log into, you will find a different representation of this kind of information. But starting for now, you can also correlate this whether this is in terms of ORAN architecture, this is grouped into near RT or non-RT. So I would like to say that our effort to see the status of the cells, and we now can only see the status is in service, this is the part of operation and maintenance function. And what do you think, Jay? It is included on near real time or non-real time?
For the status, it should be in non-real time.
Yeah, I mean seeing the status. Seeing the status. How the system gets, you know, what we are accessing now is HEPNet gateway, right? But actually we are trying to see the status of E node B, which is in service. So Richard, what do you think? This is OAM is a part of near RT or non-RT part?
Operations and maintenance.
Yes.
Let me check. Let me think.
Yeah. No problem. For me, I also try to remap again because actually we are talking the same thing, but in terms of ORAN, they have their mapping, right? So we just to know what is the mapping here.